All right, welcome to another edition of Science Bros. I am Mr. Jeffers, and today I'm going to walk you through a video of vapor density. So we're going to look at the densities of two different gases here. The first gas we're going to look at is methane. Luckily, we have natural gas lines here, so we're going to be looking at methane, and then we will also look at the density of hexane. So without further ado, let's just jump right into it. The first gas we're going to deal with today is actually going to be methane. So we have a methane pipe here, basically. So this natural gas line is connected to our pipe here. And what we're going to do here is I'm going to take a little bit of this solution here that's in this tin can right here. And this is actually just a little bit of bubble solution, what you might play with on a nice summer or spring day. And what I'm going to do here is I'm going to see if I can create some methane bubbles. Just ever so carefully inflate it here. We don't want it to be too large or it'll pop the bubble. And I want you to pay very close attention. What happens to the bubble right as I release it from my funnel here? What's going to happen here? You know, without lighting anything here, let's just see what's going to happen. And look at that, it floats up. So what can we infer about the density of methane in relation to our surrounding atmosphere? So our atmosphere is made of oxygen, which is what we breathe, and a lot of nitrogen. So what we can infer or figure out here is that methane is going to be less dense. It's going to be lighter than air. That is why it's going to float up. It's the same thing like helium or like hydrogen. Both of those are less dense, and they are also going to float up if we release them, at least in our atmosphere. But another cool thing we can do is that methane just so happens to also be flammable. So what we can do here is we can apply a flame to our methane bubble if we do it very quickly here. Mr. Hendershot is holding the camera, and he's also going to try and light it at the perfect time here, and I will release the bubble in 3, 2, 1. Whoa, a little late there, We'll do another one here real quick just so we can see it. So again, the nice part about methane is it is flammable. It will ignite. So we will release it here in 3, 2, 1. And look at that. We get a nice little controlled burn. And one more because, hey, why not? It's pretty fun. In 3, 2, 1. Look at that. So that is our first gas. That is our first gas, methane, and we can do something else as well. So we just saw that we can make bubbles with methane. Now we can also make some other types of bubbles by mixing a little bit of methane in with our dish soap solution here. So this is just regular old Dawn dish soap, and what I'm going to do here is I'm just going to take our hose right here and make a few bubbles. So we have our few bubbles here, and the nice part is I'm going to show you a cool little trick that I recommend you do not try at home. Again, I'm going to repeat that, do not try this at home. And I'm going to show you a little trick where you can actually hold a little bit of fire in your hands. So to do this though, we got to take a few precautions. We got to make sure the sleeves are rolled up so nothing catches on fire, and then I also need to douse my hands in just regular water, because the nice part is water can be a great thermal insulator, and it can make sure that the heat from the fire does not transfer to my hands and burn my skin. So right there, I have the methane bubbles in my hand, and I might need Mr. Hendershot here again to light it for me real quick. And all we have to do is hold it in my hand, watch very closely. Woo! And look at that. Look at that. Not a single burn. It burns very quickly, and my hands are completely protected because of the water providing a nice barrier there, protecting me from the heat, because it's not going to conduct the heat very well. And let's see it again just one more time. It's pretty cool. I'll get more bubbles here. There's that. Douse my hands in the water again just to be safe. And there you go. So that is fun with methane. Now we'll move on to hexane.
All right, now on to part 2 of this vapor density demonstration. And we saw a little bit ago about methane, and it's lighter than air, and so it is rising much like helium we described. But gases, it's strange to think, but gases do the same thing as liquids with densities, and they'll separate out in there. The more dense ones will be lower, and the less dense ones will be higher. And gases can do the same thing. And that's why you have to be careful if you have a hole or a tank that you're going into, that you just can't go in there, because if all the oxygen is displaced because of a more dense air, you then can't breathe because there's no oxygen in there. So it's a good safety precaution before you go into any tank or any hole. Actually, you should not even do that. A specialized person should do that. But you got to be mindful that you don't want the oxygen displaced, because that could be a big problem. If you want to research something, look at the Republic of Cameroon, Lake Nyos, and there is a story on that, a tragic story. So I want to give this demonstration of hexane to complement our last demonstration. So hexane is about 3 times more dense than regular air. Air is mostly nitrogen and oxygen, and this is about 3 times as dense. It is a colorless gas that is so it's a clear liquid, and it is a colorless gas. So you don't believe it in there, but inside there is filled with hexane vapor, okay? It's not just escaping because it's more dense than the air around us. So it's there, even though we can't see it. And another property of hexane, much like methane, is that it is a hydrocarbon and will combust when given a ignition source, like my candle, and the generous amounts of oxygen which we have in our atmosphere. So it's going to use the oxygen in our atmosphere, and it's going to use the ignition source, and our fuel is the hexane vapor. All hydrocarbons will produce water and carbon dioxide when they react with oxygen in the air. Okay, so carbon dioxide and water is being produced. So this is hexane. You'll get the safety first here with the goggles on, and you're not going to see anything poured because the gas is colorless. And then what you'll see is a spike. So when it gets there, it will spike back up. Right there. We've got to give it a few seconds to recharge. Okay, we're going to recharge it here, and we'll let the gases build up, and we'll be able to do it again. Your question might be, why did it go out? Well, the fuel could have been used up that we had already created, or what happens here is if you burn all the oxygen, use all the oxygen up inside this little container, that can also end the reaction with the flame. So let's try it one more time. And there we have it. Okay, vapor densities. Gases have density too, and therefore will behave in the same way that we would expect them to.